Hi everybody, we're the crash experts, and I'm Michaela Freeman.
I'm Elizabeth Chamberlain.
I'm Shelby Ames.
I'm Spencer Palmer.
And I'm Tyler Peterson.
We've been working with AutoLeave to upgrade a couple of their demonstrations that they take to STEM fairs, elementary schools, middle schools, and high schools and colleges. Special thanks to Aaron and Quinn from AutoLeave and all the folks over there for all the help that they've given us. Here we have the toy car crash demonstration and the headphone drop. Now we're going to take you through each demonstration specifically.
And for this part of the video, we have our headphone drop demonstration. The purpose of this demonstration was to illustrate the benefits of an airbag in a car crash. It's also supposed to act like an interactive game to teach concepts of engineering, so students or kids can learn the process of testing something, having it fail, improving it, and trying again to improve. For that, as a fail indicator, we have what's called the bistable mechanism. It acts basically like a mechanical light switch. If forces too great hit the head, it'll trigger and it'll look like he broke his neck. Just to kind of illustrate that point, if the airbag isn't full enough and the head hits too hard, the head triggers. Now, if whoever's running the demonstration succeeds in filling the airbag enough, the head is saved. For the pressure component of the system, we've decided to use a high pressure pump. These pumps are all using quick disconnects for quick reset and build times. The air reservoir is a repurposed paintball tank, which will hold the air as whoever's running the demonstration will be able to fill the bag to the tank to whatever pressure they want. And then another system will release that pressure using a quick release solenoid connected to hoses and the airbag.
So the participant experience in the headphone drop demonstration will go something like this. The participant will be able to use this pump to put air into the air tank. As they are pumping, they will be able to see on the screen the pressure will be measured using a pressure transducer, and it will continually update on this screen. Once the participant has their desired amount of pressure in the tank, they'll be able to choose their timing of when the head will fall and when this valve will open the air into the airbag. As the goal is to minimize the acceleration experienced by the head, there is an accelerometer mounted in the head that will measure the acceleration of the impact, and it will report the information, the peak acceleration information to the screen, and it will become like a game for the participants to minimize the acceleration experience during the demonstration.
So here we have the toy car crash demonstration. The purpose of this demonstration is to illustrate the importance of a seatbelt and an airbag, as well as illustrate Newton's second law. So here we have the smart cart that records force and acceleration with a 3D printed sled on the top. We have an avatar comprised of 4 different pieces that sits in the sled. We have an airbag and then a seatbelt. There are 3 different scenarios. We have no seatbelt, no airbag, where the avatar explodes. We have a seatbelt where the head pops off, and then we have seatbelt and airbag where the avatar stays intact.
For our aluminum track, we have a quick release pin so that the students can participate. We also have 3 different levels to simulate a slow, medium, and high speed crash mode.